everyone, my name is Rajendra. I have more than 10 years of experience in the IT industry, and from last 5 years I'm into the training field, and I'm associated with Cognixia from then. So we do deliver a lot of trainings if you see. Okay, so Cognixia actually partnered with Red Hat as well as Microsoft. Okay, so if you see more than 1.5 lakh professional trained till now, and we do deliver training in more than 55 countries. In Cognixia, we provide all these different types of trainings. Okay, if you see, all these technologies are in a boom nowadays. There is a lot of hot requirement in the market for AI/ML engineers. Okay, designing microservices, doing RPA automation. Okay, IoT, DevOps, cloud, security. Okay, so all these are very hot requirement, and there is a huge opportunity for everyone uh, to gain the knowledge. Okay, because here in the Cognixia we give live trainings where you can ask the question. Okay, you get your all the doubts will be get resolved. So we'll discuss about if you have any more question on any of the course at the end. So before that, let's start with the topic. So the topic name is leveraging a DevOps mindset for the digital world. So if you see, last 1 year now, everyone is working from the home. So now to work from home, you need something, right? You need internet access, you need remote systems from where you can connect and all stuff, right? So now to provide all these systems automatically as and when required, once your task is done, if you want to decommission those servers or systems, so for that no one is manually doing that. So all this is automated. Okay, so who is doing that? This automation tools are doing that, and DevOps is nothing but automation. DevOps is all about automation. If you talk about like 10 years back or even last 5 years back as well, all the whatever the software development life cycle we have, okay, all the steps were happening sequence by sequence, and hardly there was any automation. People were doing all this stuff manually. Once your development is done, doing that build manually. Once build is done, you are shipping it to the testing team, then they were doing the testing manually. Once the testing is done, then you're putting it on some staging environment. Okay, so all this stuff was happening manually, and now we are doing all this automatic. So who is doing that? Who is helping that? It's the whatever we tools we use. So by using all those tools, we do automate this, and using or understanding or having knowledge of all this automation tool, that is nothing but your DevOps engineer's job. So DevOps engineer or the DevOps technology is nothing but it completely automation. Okay, so this is what we can call it as again a definition. DevOps is all about automation. So basically there are three major stakeholders involved in the DevOps. So one is the major is the development team, your QA team, and then your operations team. So to make the communication between all these three entities or the stakeholders, DevOps is very critical, and with the help of DevOps we can automate all the communication between three entities. So if you have any very huge project, and if you want to build that project, once build is done, if you want to ship it to the testing team, for testing team as well, they don't need to specifically run test cases one by one and then give the feedback to the development. With all this means whatever we were doing 5-10 years back, all these processes are automated using DevOps tool. And then having understanding or having knowledge of all this tool is, that is why we call it as a DevOps engineer, or the DevOps process we call it as. This is a typical DevOps life cycle, we can say. So apart from planning stage, okay, so if you see what all the steps are here, initially what happens, we get some requirement from the client, we analyze that requirement, we understand that requirement, and depending on the requirement we plan that requirement. Okay, these are the 10 things. Okay, this is project under that. These are the 10 things that we need to do. We plan all the things. Okay, we do the proper designing. Once designing is done, we can assign that, means we can provide this design documentation, everything stuff to the development team, where all the coding will happen. Okay, whatever the product design we got from the design team, we do the, means as a developer they will do all this development for that product. So once product is ready, we need to build that. Okay, we need to build that, and then we need to create some executable. Through that, once your executable is ready, you can directly run that executable somewhere. So again, depending on what programming language, okay, or whatever the tools, technologies that we have used in the coding, we need to decide what all the build tools required, and accordingly we build our project. Once project is built, we need to give that project to the testing team, where testing team, according to the features or whatever the requirement we got, according to that they will design their test cases, and then those test cases will be run against the development that the developer has completed. So once the testing is done, if everything goes well, we can release that. If there is some issue, the testing team will give that feedback to the development team. The development team will work on those feedback. They will try to improve it, or whatever the bugs are there, they will provide the fix to that. Once that fix is done, again we need to rebuild it, okay, because we did some changes in the code, so we need to rebuild that. So once build is ready, again we provide it to the testing team, okay, where again all the test cases will be run. And this time, let's say now there is all the test cases are passed, so this product is okay, so we can release this product. Okay, we can create the release binary. So once a release is ready, so we can, maybe if we have a local environment where we can deploy that, so either we can first deploy it on the local environment, validate all the things, or if once that validation is done, the similar type of deployment, or maybe on the some large scale, we can plan the deployment, and then that type of deployment will do it under either in the client environment or maybe in our local environment. So now, earlier all this were happening manually, okay, like setting up the required environment, then deploying your application, then validating whether it is working, not working. So all these steps we are doing manually. So we'll talk about it like in the DevOps, how or what are the tools that we use to validate the deployment, or how we can automatically do the deployment. So once deployment is done, we need to see that, okay, we need to validate, or we need to do the maintenance of that, okay, or if there is any change required, or is operation activity that we need to do, so that we do depending on the that situation, or that type of environment. So that is done in the operation state. And then once everything is running, everything is okay, you need a monitoring of that as well, okay, because let's say you deployed some service, and due to some reason that service is not running, or maybe it got stuck somewhere. So if we have a monitoring mechanism through which we'll understand that, okay, out of this 100 services, these 2 services are not running, or got stuck, or not responding, so all this information we need to monitor it. So now if we talk about earlier days, like maybe 5 or 10 years back, we're having some small we are not having very great tool to monitor that, okay, but nowadays there are a lot of interesting tools are available in the market through which we can monitor our complete deployment. Now in any of this stage, if we again face any problem, again we need to inform that again back to the development, like this feature is not working here properly, or there is some break, or there is some gap, or we need to improve this. So all this requirement will keep coming, and then accordingly we need to again plan on those requirement, we need to again code on that, again build that, again give it to the testing team. Okay, so this is complete cycle, and it will keep going on. So this is how the typical DevOps cycle works. Now this actually we are doing manually some time back, okay, but nowadays this complete whole cycle is completely automatic. You don't need to even interfere anywhere. With by using DevOps tools, we can automate this complete cycle. Okay, so we'll talk about it in which stage, which tool we can use. So that stuff we are going to talk about it. Now, if you see the typical DevOps timeline, so the first DevOps concept came in 2007. Developer called Patrick DeBoles. So basically, that guy started assessing like we need to automate this. Okay, we are doing it manually. It is taking a lot of time. So that guy actually initially started on that, and then after that, some other developer or some other company day by day they started developing some tools, and then by using those tools, people were able to automate the stuffs that we are doing manually. And then you can see the by if we proceed further, like 2009-10, there are some tools were invented, and in the industry those were well accepted and very popular, and nowadays everyone is using those tools, and the whole our software development life cycle got automated. And due to that, the advantage that we get is the time to market, okay, or the time required to let's say you got one requirement. So once you got the requirement till the product is getting delivered, whatever the time required earlier, that is getting hugely reduced due to this DevOps tools, because everything is getting automated, and due to that, whatever the development of that product is, that is getting very fast. Along with that, if there is any issue in between, that is also getting to know very early stage. Earlier what was happening, like if you got the requirement, until and unless you are not testing it, or you are not properly deploying it, you are not able to understand if there is any problem in the product. If you get that problem, then you will report it back to the developer, and they will then again do the development. Here as well, the same thing is going to happen, but here we are not going to develop a complete product at a time. Basically, in the DevOps, what we do is we divide all this the complete our application, we are going to divide in a small part, okay. We call it as a module, or we call it as a small microservices. So we'll develop all these small modules or as a microservices, and they will be developed independently, they will be tested independently. At the end they will be integrated. So whatever the small things or small bugs that earlier we are getting to know at the very end, but with this automation or with this microservices concept, we are testing it very frequently, and due to that, actually we are getting to know that okay, there is a bug and we need to solve it. That we are getting to know on very early stages. So let me take one example. So let's say developer create or develop some code. Now let's say your development is done, let's say at 6 o'clock. So usually people leave the office around 6 or 7, around that. So now the testing team will come on the next day, and they will start, okay, I'm talking about the earlier scenario. Testing team will come on the second day, and they will start testing it, and by end of the day they will come up with like, okay, these are the 3 bugs we found, and you need to fix that. So now the developer will come on the third day, and it will start working on those bugs, and on the end of the third day he will fix it. Then on the fourth day, your tester will come and again test it, okay. So you can see, like, typically to fix one bug, we are identifying the bug and then fix it, we need 4 days. But when we are talking about the DevOps, so in the DevOps, for whatever the processes we are doing, like once your code is done, to build that code, we are having tools. Once the code is built, to test it, again we have a tool. Those will directly those tool will run some already created test cases by the QA team on that product, and then once test cases run, whatever the feedback of that, whether it's a success, failure, those feedbacks will be shared to the testing team as well as the development team. So let's say the developer developed that application, we got it at 6 o'clock, and while going, you can just start running like testing and all stuff. By tomorrow morning, in fact, whenever the test case is done, you'll get to know that, okay, there is some issue in this particular module or somewhere. So what you can do, when you come to the next day, you can start directly fixing it, and you can fix it and again run it. So here you don't have the dependency. Automatically, like, all these steps are happening, and you are getting to know that, okay, there is some problem and I need to fix it. So due to that, what is happening, the time required to create a release package for your deployment, it's getting highly reduced. Earlier, if you see, one release cycle people were creating for like around 1 month. So due to this, all the DevOps tool and all this automation, now that cycle is on the 1 week. On Monday, we are getting the requirement, and by the end of this week, we need to release that. But that is possible because with all this testing to all this DevOps tool, that is getting very means it's all these tools are matured, and we are getting all these outputs or the bugs, okay, all this getting very quick, and due to that, we are able to complete that development, and all this package creation, build, testing, all this happening very quickly, and within a week we can release that particular feature. So these are a typical example I was saying. Now, what all the stakeholders those are involved? So here major stakeholders are development team, your operation team, and the QA team. And to assist all these three teams, we need DevOps guys along with DevOps tools, so that whatever the interaction between all these stakeholders can be automated and we can deliver our product very fast. Now, we talked about some goals or the advantage that we get. So the first that we see the feature or the advantage that we get with the improved deployment frequency. So because here now we have all these tools, and due to that all the development, build, testing, everything is getting automated. So due to that, instead of having your deployment cycle for 1 month or 15 days, that is getting reduced to on 1 week. So that's why we call it as improved deployment frequency. Now, if you are developing one feature in a 1 week instead of 1 month, obviously your time to market will be fast. Earlier, let's say to develop a complete product or release that complete product, you are taking around, let's say, 4 months, but here that is getting reduced to around 1 month. Okay, so instead of 4 months, now you are able to release that product in a 1 month. Now again, here all the, let's say, testing or build procedure are going to happen automatically using some DevOps tool. So obviously we can trust on machine instead of human beings, because humans can make a mistakes, but machine can't. Okay, whatever we are saying that, okay, these 4 steps should be happening this way, and if we train our system, the system will exactly check that way only. Okay, these 4 steps should be running this way only, and those steps are running that way only, then only you will get the success. But when these 4 steps are checked by the human, then there are chances that like we miss something, and then there is a not a exact accuracy. So that's why the failure rate with all these automated tools is less as compared to what we are getting earlier. Now again, to fix the bugs, again all these tools are there, that obviously is the fixed timing or the bug fixes timing that we are required, that is definitely going to be less. Again, if something got failed, if you want to recover that, that is also due to this. If you talk about like the tool like Kubernetes, where let's say you have released one feature, and after releasing you get to know that, okay, there is some problem and you need to revert whatever the release you have done. So within a second, without any downtime, you can quickly revert it back to the previous feature of your deployment. And due to that, the recovery time is required for your failure is a very less. All these tools are providing security, okay, easily maintainable, they are efficient. So all these features are there. So now let me show you. Let's talk about first what is the future of DevOps. So you must have observed, like if you are exploring something, you'll see that, or maybe if you are looking for a job change, or if you are look at the market, like how it is flowing. So if you'll see that every organization is talking about the DevOps. They want to automate their whole development life cycle. They want to make sure that the time required to develop your product, it should be reduced, and that can be done only through the DevOps, okay, or DevOps tools, because the whatever the legacy technologies or legacy way of developing product, it's not working now, because it's taking more time as compared to the one that we are getting with the DevOps tools. So that's why in the market there is a very huge requirement for the DevOps, and even the packages that we are getting are more than the developers what they are getting. Okay, because there is a high requirement, there is a high demand, and the supply is not that much. Okay, people are still don't have much experience on or whatever the tools that are used in the market. So that's why there is a requirement is very huge, but the supply is not there. That's why whatever the package you ask for, you will get it. Let me show you first what all the tools, in which particular stage which tool is used, and then we'll talk about some Kubernetes part, because Kubernetes Docker is playing very important role in all our software development lifecycle. So what is the role it is playing? We'll talk in a bit. Before that, let's see what all the tools are used in each of the stage of your development DevOps life cycle. Now, those who are developer. Okay, you might be knowing all these tools that we use for development. Okay, so if you see on the left hand side, while coding, okay, if you are a developer, okay, you need to have a knowledge of like, okay, so this for this particular stage actually, developer plus your DevOps engineer will be involved, because let's talk about the developer. If he's writing code in some, let's say for Java, you need to have a knowledge of the Eclipse or whatever the IDE you are using. Apart from Eclipse, some people use Visual Studio if you are developing it in the C# or some Windows related languages. Again, parallelly, you need to have source code management tool knowledge like Git. Okay, Git is very popular. There, what is the use of source code management tool? Because let's say you are developing some code, you need to store it somewhere so that if any other developer wants to use that, he can use that code. Okay, along with that, we can maintain the multiple branches as per our feature, or as per our developers are working on the 4 different feature. Okay, so now they can't work everyone on the same branch. Okay, we need to create separate branch, and they will work on their own branches, and then at the end we can merge those branches onto the one branch. So all this type of management can be done with some source code management tools, and out of that, this Git is the popular one which is used in the market. Now, there are a lot of other tools as well, like Perforce, Maven. So all these tools are there, but most popular, if you see, like Git is the most popular that is used in the market. Now, once your code is done, okay, and your commit is done, okay, so code management, we mostly use the Git, and in our DevOps training as well, we include only Git. Okay, because now if you see, we just mentioned a very few tools here, but you cannot cover all the tools, right? But whatever is the popular and used everywhere, that is Git. So we have included that in the course. The next phase is build and config. Now, when you develop any code, you need to build it. Now, if you have developed your code in Java, so there are tools like Maven, Gradle. These tools we can use to build that. Then if let's say if you have developed the code in C or C++, then you need tools like CMake. So like this type of build tool we required. So in the build, all these tools are there through which we can automate your build process. Now once build is done, if you want to configure the, let's say once your project is ready, you want to deploy that project on some server. Now when you're deploying on the server, you need some configuration on the server. So there are a lot of configuration management tools are there, like Ansible, Shape, Puppet. These tools are there through which we can do this infrastructure configuration. Now out of this, like Ansible, Shape, Puppet are very popular. Along with that, there are some other tools as well, but these 3 are more popular, and that is mostly used in the industry. After your build and configuration is done, then we need to test it. Now for testing, again, depending on the what programming language we have used, depending on that, the testing tools are used, like Selenium, okay, like SonarQube, BlazeMeter, okay, so JUnit, Cucumber, all these. There are a lot of testing tools are there. We can use those tools depending on our programming language that we have used, or depending on our requirement. Once your testing is done, you need tools through which we can release it. So here we can use like Collabnate, we can use, okay, or udeploy, through which we can automate all this release and all this. So here we can use whatever the tools that you see here listed. Now for deployment, okay, for deployment, the major requirement is to set up the production environment. Okay, now to set up the environment, we can use any cloud service provider, or we can create our own environment using Kubernetes, Docker, or we can use it from the service provider like VMware, Azure, AWS, third party like open source tools like OpenStack. So all this we can use to deploy your product as well. So these are the some tools that is used to automate it. Nowadays there are a lot of tools are coming, like okay, so one more tool that I missed. Do you see here Jenkins? So Jenkins is again a very important tool, because to integrate all these tools under Jenkins, and where we can create a pipeline. Okay, so pipeline means we can mention like, okay, first you need to do build, then you can test, okay, then after that you can do the configuration, you can do the release, you can do the deploy. So we can create one pipeline, and according to the sequence that we have specified in that pipeline, according to that, the process will be automatically done. So we'll see more on Jenkins part, like how Jenkins is helping us. Okay, you can see here the Jenkins is actually on this circle. So Jenkins will help us to integrate all this tool together, so that the whole DevOps lifecycle can be integrated together and can be automated using all these tools. So now at once we don't use all these tools, okay, maybe one or two from each category we use it, and only out of this, depending on your requirement, those are popular. But let me tell you, most popular tools like Git is very popular, that is mostly used. Then here in the build, mostly Maven or Gradle is used. For configuration, nowadays Ansible is very popular, okay, but earlier that Shape and Puppet were there. So this why Docker and specifically Docker containers are used, because let's say you want to create a build server, okay, so now it's not easy to set up a virtual machine and then do the build on that machine. It's a time consuming process. But if we have a Docker like tool through which we can quickly launch one container, and inside that container you can create the build, and then that build you can pass on to the next stage. So to create all this intermediate systems quickly, do your stuff, and once that is done you can revoke it. So for that type of requirement we can use the Docker here. Now if we talk about the deployment, okay, deployment is very critical stage where we need to think of like how many systems are required, or how many how you need to deploy that application, where how is there any load balancer required, how we are going to manage the storage, is there any cache database is required, how we are going to replicate the database. So for all that you need a proper environment, okay, and that environment can be provided by either you can use any third-party provider like a cloud provider, or you can create your own environment with the help of Kubernetes. Okay, so that's why Docker and Kubernetes actually a very critical part of the complete your DevOps lifecycle, because everywhere you need an environment, and then that environment you can create it from the Kubernetes, okay, with the help of Kubernetes. So that's why again Kubernetes is very critical here. And then Jenkins is there, okay. Jenkins is again to integrate all this stuff. Jenkins is also very must part. Now let me just show you the typical one sample workflow, how we can set up that workflow with the help of Kubernetes. So now if you see on the left hand side, okay, let's say developer created a code, and that code committed or pushed on the Git. So with the help of Git, we can push that code on any of the Git repo, okay, whether we can have our own private repo or we can push it on the public repo. So now there are some mechanism. In fact, we use the Jenkins here, through which we can add the webhook on our GitHub repo. So as soon as any commit, a code commit happens on any specific branch, whatever we have mentioned in that webhook, automatically that information will be sent to the CI server. Okay, so CI, we actually in a DevOps we have some terms like continuous integration, continuous deployment. So what that mean? Continuous integration means as soon as you get the code on the Git, any new code, automatically with the help of webhook, we'll get that code on the CI server. So once we get that code on the CI server, where we'll have a build machine setup. We will have a build machine where your code will be automatically will be built. So once your code is built, we can create an image out of that code. Okay, we can create one image, okay, container image, where all the your application, all the requirement will be bundled in one image, and then with the help of that image we can create one container where your application will be running, and then there will be some automated test cases will be there created by the QA team. So we can run those test cases on the application running inside the container. So once all the test cases passed, what we can do is that same image we can pass on to the Docker repository. Okay, we call it as if it is a we can set up our own private registry or a public registry. The public registry that we have available is a Docker Hub, where you can, if your code is not it's a proprietary code, you can definitely push it on the remote repository. We call it as a Docker Hub. Okay, so we can push it there, or if it is a proprietary, you can set up your own private repo where you can push that image. Now once that image is ready, we can automatically Jenkins will create one job that will pick that image and it will pass on to the Kubernetes, where again we can write some script and we can define our requirement, like, okay, I need this many pods. Okay, so in a Kubernetes term, actually we call it as a pod. Okay, in a Docker term, we call it as a containers. So there are some small differences, but we'll talk it in our course. So we are going to deploy our application as a pod inside a Kubernetes, where we'll have a lot of flexibility, like we can monitor our application, we can do the health check of that. If due to some reason, if your pod gets terminated, will Kubernetes make sure that there is another instance of that pod will be running. So due to all this, the inbuilt support from the Kubernetes, your application will be always in a highly available environment. Okay, so that will make sure that the users, those who are accessing your application, they will get the continuous access for the application. So we'll talk about the complete process in a bit, but before that, let me just this is again a similar cycle, you can say. Let me just quickly walk through this and then I'll show you quick demo about Kubernetes, how we can quickly deploy your application, how we can make it highly available. So this is again similar to what we discussed in the previous slide. So once we push the code on the GitHub, image will be, means that with the help of webhook, we'll get to know that there is a new code. So there will be a build server that will build your code and it will create the images. Once the image is ready, we can push it on the Docker Hub. Once they pushed on that, from there we can pull it in our deployment environment using Kubernetes, and we can deploy it on any third parties, means cloud providers, or we can set up our own production environment with the help of Kubernetes, and we can deploy our application. Let me go back to the Kubernetes cluster. So this is my Kubernetes cluster, where if you see CTL gate nodes, so here you can see that I have 3 nodes. So one node is there to manage the cluster, and these 2 are the actual worker nodes where your actual application is going to be deployed. Now, basically, how we deploy this application, the way we talked in our previous slide, that we create the images of that application, So to create the images of those applications, we use Docker. Okay, with the help of Docker, we bundle our application along with all the requirement in one package. We call it as an image, and those image reference we give it here, so that what happens is when when you want to deploy an application, we just need to specify the image reference. So this Kubernetes will pull the image from the Docker Hub registry and it will start the application. Okay, so let me show you one simple application. So there is a Nginx image. Okay, Nginx application image is available on the Docker Hub. So how we can use that image? So let me create one pod here. So how to create the pod? So we have a Kubernetes CLI, kubectl run. We can provide the name to our application. Let's say this is my app. Then we can provide the image of our application. Let's say the image that I'm going to use for my application is the Nginx. Instead of Nginx image, let me show you one simple application that I have. Just give me 1 minute. I'll show you that application. So if you see application, it's a simple Python application. It's creating one just Flash server, and when we try to access this application, it will simply return me the message, hello from container world. Now, if you want to deploy this application on the, or if you want to create a container of this application, first what you need to do is, first we need to create an image of this application. So how to create the image? So to create the image, we need to write a Docker file. Even if you don't understand writing Docker file, and that is very much fine. Okay, but let me just quickly show you that how it looks like. So here, if you see, I'm just creating an image for my application, where I'm saying that, okay, so my application is running on 8080, and these are some requirements for my application, and then this is the basic environment, or this is the requirement for my application, like a Python must be installed. Okay, and then there is one basic image is used. And as soon as we run the image, this app.py should be run. So this is how I'm just creating it. So to build the image or the create an image for your application, it's a very simple. We just need to run docker build -t, and then we need to give the image name. So let's say I'm just giving the name as a demo. Okay, and we can give the version number as well. And then we need to give the path of the docker file. So if I run it, you can see that whatever the steps that we have mentioned in the docker file, according to that the image got created. So if you see docker images grep demo, you can see that our demo image got created 1.0. Now if you want to push this image on the repository, okay, so we need to push this image first on the repository, then only everyone can use this image. Okay, if it is on your local system, right now this is on my system only. Okay, so from here no one can access it. If they want to access it, I need to this copy this or create a tar out of this image, and then this tar file I can share it with someone so that they can use it. But here instead of sharing that way, because again there are a lot of business, when we build this image, if you see, it built a layer by layer, like whatever the steps that we have created, it got built step by step. So basically when this image internally built on the basis of some layers, okay, it actually stores the hash of the previous layer. So all these are interlinked. So due to that, you cannot directly copy your image to other system. Okay, so there is some mechanism is used. So that will not talk about it right now. It has some interdependency, that's why we cannot copy directly. Okay, so for that we should store it on some repo. Okay, we can create our own private repo, or we can use the public repo that is available. We call it as a Docker Hub. So if you want to push this image on Docker Hub, what we need to do is we need to create an account on the Docker Hub. So I have already an account on the Docker Hub. So what we need to do, we need to tag this image with our Docker ID. So how to do that? Docker tag, I want to tag demo 1.0 image to my Docker ID. Okay, so my Docker ID is Rajendra IT 99, and then we can give slash and our image name, that is demo 1.0. So now if I run it, and if I again do Docker images, so you can see that this time there is a new image reference got created with Rajendra IT 99/demo, and this is the version. So now if I want to push this image on the Docker Hub, how I can do that? Docker push Rajendra IT 99, this is the Docker ID I'm using, and then the image name. So now if I run this, what it will do, it will push this image on my Docker Hub account. So now from there, this Docker Hub is a public. We can make it as a private as well. So this is, for now it's a public, by default it's a public. So if someone wants to use this image, they can simply pull that image from there and they can start using. So what I'm doing is, now image is available on the Docker Hub. So what I'm going to do is I'm going to create one pod here. So let's create it, kubectl run. Okay, so before that, how to see if there is any pod running or not, what we can do is kubectl get pods. So if I run it, you can see for now there is a no pod running, but let's create it now. Kubectl get kubectl run my app hyphen image. What image I am going to use is Rajendra IT 99 slash the image name that we have given. What was the name? Demo 1.0. So if I give this and if I run this now, you can see that pod my app got created. If I do kubectl get pod, you can see that it's now creating a container is getting created, and now it's in a running state. So if you see kubectl get pods -o wide, you can see that we have seen that there are two, in fact, three nodes were there. Out of that, one was the master node and two were worker node where actually pods will be deployed. So here you can see that whatever the application that we have created, that got deployed on the kind worker 2 node. So if you see our node names, kubectl get nodes. So three nodes are there. Out of that, this particular application got deployed on the kind worker 2. So how to access this? To access this application, again we need to create one more entity. We call it as a service. In a Kubernetes term, we call it as a service. So service will help us if you want to access your application outside your Kubernetes cluster. We need to create a service. Okay, so let's see how to create it. It's again very much simple. kubectl expose. We want to expose pod. Which pod that we have? It's a my app. So I'm giving the service name as my svc, and then I'm also giving the type hyphen type. Okay, so there are basically two different types of services. One is node port service and one is cluster IP service. Okay, so I'm using here node port for now, and then the port on which particular port our application was running. You see our app.py. Okay, it's running on 8080 port. So I'm giving the port as 8080. Okay, so this much the configuration that we need to provide. So let me run it. You can see that service got created. How to see the service? kubectl get svc, or you can type the complete as a service. So you can see that the service got created and it got exposed on the 3849 port. So basically there is one concept called node port, so that actually the service binds your application port with your host machine port so that you can access the application from external world as well. Okay, so that's why we are binding this. Means this automatically the application port and the node port will be bind when we create a service of type node port. So now if you want to access the application, what we need to do is, if you see kubectl get nodes hyphen o wide. Okay, this hyphen o wide actually give more information that. Okay, so I'm taking one of the node IP. Okay, I'm trying to access the application now. If you see 31849 is the port that we are using. So if you see now I'm trying to access this application. So why I'm using the curl is something like a command line browser, you can say. So in the browser, the way we write like http colon the URL and some port number, and we access the application. So similarly, if you don't have the browser, if you want to check the or validate your application, we can use the curl command. Okay, so curl is a command line browser. So through that, I'm trying to access the application, and you can see application is accessible. Okay, it is returning hello from container world. So our application is running and we are able to access our application. So that's it from my end. Thanks for joining everyone.